This is chemistry question 52 from IMAT's 2018 past paper. So I'll be answering this question. Which of the following statements, if any, are correct for properties of group 1 elements? So we must recall the main things about group 1 elements. So we generally know that there are some elements like lithium, sodium, and potassium. So these are the common elements we know. So apart from this, what's most important we must know is that group 1 elements have valence electron, one electron only. So it has one electron in its valence shell, the outermost shell of this element that has one electron only. So since it has one electron, and we know typically if we move to the left side of the periodic table, it has more ability to lose the electron to form an oxidation state of +1. So it loses one electron. So it's basically highly reducing element. So because it gives away one electron, and since it has one electron in its valence shell, it forms oxidation state mainly of +1. So these are main key points we must know for solving this question. So now let's move through these three statements. The first statement says they form hydrides when where the hydrogen has an oxidation state of -1. So yes, this statement is correct. So why is that? So here alkaline metal, so alkaline metal, which is the group 1 that we're focusing on, has oxidation state of +1 that we've discussed, and the hydrogen that will form ionic bonds with this group 1 element has its this hydrogen has its oxidation state of -1. So why is that? Because we know when we compare, sorry, it's the wrong spelling, hydrogen. So why is that hydrogen forms -1? Because typically in most question when we solve, we always mention that hydrogen forms a proton losing electron, like in most acid-based questions. But here it forms hydride, which is hydrogen having oxidation state of -1. So when we compare hydrogen with alkaline group 1 metal when they form ionic bond, here hydrogen is highly electronegative compared to this alkaline metal group 1. So why is that it's highly electronegative? Because this hydrogen has only one electron, so it has higher ability to gain the electron and pull the electron density towards itself, the nucleus of this hydrogen, which has one proton only. And more important than that is the alkaline group 1 metal generally are more electron releasing. So they basically are good reducing agent. So they basically lose electron easily. So that's why the hydrogen gains an electron, and since it's highly electronegative compared to this group 1, it forms an hydride with oxidation state of -1. It has gained one electron from this group 1 element. So that's why it's correct option. So we generally know that there are some basic compounds like sodium hydride, potassium hydride, and there are some other complex metals. There are complex hydrides that they can be formed, which are like lithium, aluminium hydride, and the other one is sodium borohydride, and also silver hydride. But this is in transition metal, so we don't really need to focus on this, but I'm just showing some simple list of compound that can form hydrides. So these are the lists, the general list that can form hydrides. So statement one is correct. So let's move to the second statement. So the second statement says they can reduce iodine to iodide. So this is also correct. Why? Because we know that iodine belongs to group 7, which is the halogen groups, halogen elements. So they have tendency to gain an electron, so they form an iodide. So we can form redox equation, but here we're going to form half redox. But before that, I want to show the full equation. So let's take from the basic one, the sodium. So sodium reacting with iodine to form sodium iodide. So we know the oxidation state on sodium is +1 and iodine is -1. So these are the oxidation states over these elements on this compound. So yeah, this is ionic compound. So if we focus on half redox, we can understand which one gains electron, which one loses electron. So the electron transfer between these elements. So the one that's being oxidized, which is loss of electron. So that is the sodium, as we discussed, that as you move more towards the left side of the periodic table, the more tendency they have to lose the electron. So sodium gives sodium plus the cation and one electron, since it's one electron in valence shell, and the one that's being reduced, which is the one that gains electron, it is iodine. Iodine gains one electron, so to balance this equation, it must be two electrons. So two electron from, and that's why we wrote the coefficient to sodium. 2 moles of sodium is required to reduce iodine molecule because the iodine exists as diatomic. So this gives two iodide ions. This is anion. So yes, group 1 element are very good reducing agent in reducing this group 7 halogen iodine to iodide. So the statement is true. So let's move to statement 3. Okay, so the statement 3 mentions their outer electron are delocalized when in the liquid state. So this is also true because group 1 metals do, the pure group 1 metals do possess metallic bonding. So they do form a metallic bonding where the C of electron, the C of electron is delocalized. So where the C electron is formed is from the valence electron, the valence electron, and they're delocalized. So C electron from valence electron are delocalized to form lattice structure. So this exists in both the liquid liquid and solid state. So they both exhibit electron delocalization within their lattice structure. But this lattice structure belongs to mainly solid, but even if they're in liquid, like when they're in their molten state, they can uh, form metallic bonding while still being in liquid state because of delocalized of sea of electrons. So that's why statement 3 is also correct. So option A is the correct option. So that's how we solve this question. So basically, you just need to know the main two key points to solve this question, which is the valence electron. There's only one electron in the valence shell, and the oxidation state that it can form is +1 as it loses out only one electron. So if you remember these two main points, then you can easily solve this question. And that's all. And this is how we solve the question. So thank you guys for watching my video. I hope you found this helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.